Hi everyone, welcome to this very special episode of CISPA TLDR. We are not in a recording studio, actually we're not in a recording studio very often, usually we're just hanging around the CISPA offices, but this time we're at the fair in Vienna. Actually we're at the 41st edition of the ICML, the International Conference on Machine Learning. And here with me is Krikamol Muandet. Hi.
Yes, hi Tobias.
He is a faculty at CISPA who works in machine learning, and I think I will just leave it to him to tell us what exactly he is working on.
Oh, hi everyone, I'm Krikamol, and we are here together with Tobias in Vienna at ICML. So first of all, I think ICML, for those who don't know, ICML is one of the flagship conference in machine learning. So every year, almost all of machine learning researchers come here and to discuss recent advances in the field, including myself and my team, who basically come here this year as well to present our work at this conference. And to tell you a bit about what I've been doing or what my group have been working on in the past 2 years, I would say, is basically the motivation for our research is that AI has been creating sort of breakthrough in different areas, including science, businesses, healthcare, right, finance, criminal justice.
So basically, in all parts of life that you could possibly imagine.
In all parts of life, AI has now become a critical tool that people is paying attention to. A lot of investment has been put into AI, right?
Yeah.
But we recognize the limitation of AI, right? AI, I mean, in the end, what we are after is to create intelligence machine.
Yeah.
Right? And people have anticipated that now we have sort of something that behave intelligently, right? It can, for example, predict, the videos or the scene, or understand languages.
Yeah, or predict wildfires or
whatever.
Help in cancer detection. There's just so many things.
Yeah, there's so many applications that AI can assist human on. But we recognize that there are really several limitations, right? Just to give you a few examples, right? When we use AI to help with diagnosis in healthcare, right? For example, if you want to use AI to help detect whether a patient has certain disease or not, for example, let's say COVID-19. Typically, we use input data as X-ray images, right? X-ray images as input data, and then we want the AI to tell us whether those X-ray images belong to the patient who has COVID-19 or not. Right? Okay. And then I think what we would hope, or what the doctor would have done, is to look at the X-ray images and try to identify the medical pathology of COVID-19. Okay. Right? But what happens when people observe in practice is that when you use AI, it's used totally different feature to detect COVID-19. And it's happened that those features are totally irrelevant to the COVID-19. For example, it could be just a label on X-ray images where the X-ray were taken.
Okay, so this is just the machine. The machine or the X-ray image says, okay, hospital Vienna, and then there was a large number of cases of COVID-19 in Vienna, and the machine learning model thinks it is somehow related to.
So it's turned out that then in the end, the pattern that the machine detected is irrelevant to the disease or the pathology that we are actually interested in, right? So. And the reason for that is because, I mean, machine cannot really distinguish between different kind of correlation that we observe in the data, right? For example, another example is also that actually the AI could also detect from X-ray images whether the patient is lying down or standing up when they take X-ray images, right? And that has a correlation with the whether or not the patient is healthy or not, right? Because most of the healthy patient will be able to stand when they take X-ray images, but then most of the patient who are not healthy, they have to lie down when they take X-ray images. And as a doctor, you know, they tend to ignore these kind of feature, right? But then the machine, because of the capability that they have, right? They take all the information and then use that.
And what you get in the end as a result is results that are not really reliable, or
they're not reliable and don't even work in practice, right? Because you don't want to put that in use, right, to detect really the real. So I mean, I think a simple analogy is basically the machine is actually cheating, right? Because it solved the problem that we wanted to solve, but then they use a trick to solve this problem, right? It's like a student who learn in class, but then when the student do the exam, the student, they just cheated. They can achieve high score, but then it doesn't mean that the student understand the concept they've learned. Right?
They have learned nothing.
They have learned nothing, right? But then it's the student appear to be intelligent by having the high score in the test exam.
That's actually a very interesting distinction that I kind of read between the lines when you started your introduction. You talked about AI models or AI being intelligent machines or machines that behave intelligently.
Right.
You would say that there is a difference, right?
There's a difference in there, and I think as a community we have to recognize this difference, right? We have to realize that these capabilities, I mean, there's association with intelligence, right? But it's not yet, you know,
it's not
really
intelligent,
right? In the way that we understand it. And I think that's the motivation for us to continue doing research. I think so my group is called Rational Intelligence because we want to create machine that not only intelligent but also being rational as well, right? In the way that we want, like in the example that I gave before. I mean, if the machine classifies X-ray images as COVID-19, it should be able to tell, okay, why the patient has COVID-19.
It should actually analyze like
it should be
lung structure and not.
It should be able to reason about the decision or prediction that. Right. Okay. Yeah, and I think this is important because I think once we realize that AI is part of the society, we want to be able to trust the system, right? When we put it in the, we want to create AI that is trustworthy, safe, and reliable, right? Because I think everyone recognizes that. I mean, I think AI is going to change the way we live. But we don't know whether it's for the best or for the worst.
That would have been my next question: whether you think it will be for good or for the worse.
I tend to be optimistic. You know, I think I tend to be optimistic, and there are people who worry about this AI. I don't know. Like this Terminator scenario.
So like the worst case catastrophe, artificial intelligence, like completely eradicating human intelligence,
and then taking over the world, right? And I think that scenario is still kind of far from being realistic, in my opinion. And I think we have to recognize that there's immediate impact of AI that already happened in the society, and something that haven't actually happened yet. And we need to actually spend more time solving this immediate impact that AI has created. Like, for example, fairness, right? I mean, AI have already been used in criminal justice, for example, deciding whether people will get bail or not, right? And then deciding whether people will get loan from the bank or not, right? And that, I mean, could create like unfairness in society, right?
Especially if what you have been saying, the models don't actually behave rationally and don't are, I don't know, if they are taking things into account that actually do not matter and no one actually knows that this is happening, because, I mean, of course, explainability is also a big topic also here at the conference. Like, why does machine learning or why does AI give the results that it actually does, right?
So that, I think we need to focus on that, like the immediate impact of the AI, and not so much on something that is still too far in the future.
And do you think that these are like the biggest topics also here at the conference that the community is discussing, or what are your feelings? What are like the trends that are now? I mean, you probably have been going here for quite some time, right?
Yes. So I think the field actually has been growing pretty quickly. Yeah. And I think the trend actually changes every 3 to 4 years, I would say. I've seen sort of different trends going on. So I think right now there's a lot going on in the area of large language models. Of course, like ChatGPT, because of the ChatGPT, this kind of thing. Another trend that I've seen is the alignment, right? When you want to sort of align, or basically you want to sort of put human values into AI system. How do you align the objective of the AI system with the human values, right? And this is also quite, I don't know, it's quite subjective, right? It's actually quite subjective. And
I mean, it might be, my values might actually differ from yours, or from people that come from another culture, right?
Right. And that's actually one direction that we are also exploring as well, because, I mean, part of being rational is, being able to recognize the different in the value that many agents or many people have. Right. And then the question is, if you have an AI system, but then you have multiple agents, like many people who have different values. How do you actually align those systems with these multiple agents or people, right? What is the rational way of aligning these differences?
Which doesn't really sound easy, because that's a thing we haven't been able to do in politics for the last
I'm glad you bring up politics, because I think there's this classical result called arrow impossibility theorem, which is a very fundamental result in political science and economics. So it's basically saying that if you consider a voting system, right, and then you have an aggregation function that take as input preference of multiple users, then basically arrow impossibility theorem said that the only reasonable or rational way of aggregating these different preference is dictatorship. And that means that actually it's impossible to aggregate everyone, different preferences, unless you are being dictator.
I mean, that actually sounds pretty bleak, right?
But I think that result is interesting in the sense that it tells us exactly what we need to do to overcome this fundamental limitation, right? And that's I think something that we also recognize or actually observe in reality in like the election system, when we have to take into account multiple perspectives or multiple preferences. There's something we have to keep up, some property that we have to keep up to be able to create a democratic system.
I think it's really, really interesting that you are not focusing like solely on the machine learning part. So you're not just writing code, you're not just building models. You're actually trying to take into account many different areas of, even of science, like politics, economic science.
Yes. I think it's important to look at the problem from different perspectives. And many times, I think our research are motivated by problems that are outside of machine learning, actually. Right. especially economics, right? Because we are quite interested also in economics theory and how to use it in machine learning as well.
I mean, it makes sense, right? If you say that machine learning is, even if I just consider how much press and media attention AI has been getting in the last, I don't know, 1.5 to 2 years, I just said, if you've asked my mother like 5 years ago what AI is, she probably would have thought of Terminator, right? As you've already referenced. Yes. But today, I mean, has been so much attention in all of like the mass media that she would probably have quite a good grasp. I mean, she probably has heard of ChatGPT. A lot of people have used it and have never, I mean, touched on any of these topics. Yes. And I mean, even that, it builds different expectation also in society as to what AI and machine learning will be able to do in the future. And also there is the point of, will it be good? Will it be bad? People are also, I mean, some people are afraid of losing their jobs to it. So I think it's really, really important that we consider all of these topics.
Yes, definitely. And I think one thing that, I mean, you mentioned ChatGPT, right? And I think one thing that ChatGPT created is a democratization of AI in the sense that now people know how to use AI because you can just type, everything in natural languages and then you can ask AI to do whatever you want, right? In different languages, right? Instead of now writing code, people can just, write a text and then use it, right? So that's one thing that, this ChatGPT created, democratization of AI. And about losing job, I would say that I tend to be optimistic. I think there's a difference between jobs and tasks, right? Because jobs consist of multiple tasks. And we can, of course, use AI to replace specific tasks, but maybe not the entire job, right? We can use AI to help us do certain tasks so that we can be more efficient, right? In doing our job, right? And I think in the end it will increase productivity, I would say.
There's just the hope that the increase in productivity will actually benefit society as a whole and not just a few people, right?
Definitely.
But that has been the problem with every major invention in the last, I would go so far to say last 2,000 years, but might be a little far-fetched, but yeah. Okay, so you have been saying that you are also presenting your research here. Is there any particular thing that you are talking about this week?
So yes, on Thursday we have a poster by one of the PhD students and postdoc in our groups. And the title of the poster is Domain Generalization via Imprecise Learning. And
which is packed with a few words and I don't really know a lot about.
Do you want me to explain it a bit?
Try to make me understand.
Okay, so try to make you understand. So let me
broad strokes. Is fine. Yeah.
So I think one of the fundamental assumptions in machine learning that people often use is the IID assumption.
Okay.
Is independently and identically distributed data, meaning that when you build machine learning model, you assume that the data that you use to train the models will be will come from the same distribution as the test data.
Okay.
So that otherwise, because you want the model to generalize to the test data, so you assume that the test data look like the training data that you use, right? So in our work, we try, we relax this assumption.
Okay.
Right. And using the idea of imprecise learning. And to give you maybe an example of how we solve this is, let's say it's your birthday, and I want to buy you a gift.
Soon, you can.
Yes. And the classical way that we solve this problem is I would just buy a gift, and then I will give you the gift.
Okay.
Right. But that's rely on the assumption that I know what you want.
Okay.
Right.
Yeah.
And I have to pick a gift that make you happiest.
Yeah.
Right.
Yeah.
But what happens if I I lack that information.
Yeah.
Right. What I can do also is, I give you money, and then you can buy whatever you want.
Yeah.
Right. This will guarantee that you will like the gift that I give you. Right. But at the same time, it's also put a lot more work on you. Right?
Okay. Yeah.
So the first solution that I just told you, like directly give you a gift, is what people do in machine learning.
Okay.
We build machine learning models, and then we deployed it.
Yeah.
Right. And then we assume that everyone will be happy with the models.
Okay. Okay.
Right?
Yeah.
The second solution is when I give you money, it's like I'm not learning anything. I give you the data.
You're outsourcing the problem to me.
I outsource it to you, right?
Yeah.
And then you use that resources to do whatever you like, right? And also, these two problems are the solution that people consider in machine learning, right? The first one is create the model and deploy it. Mm-hmm. The problem is that you cannot guarantee that everyone will enjoy the model in the same way.
Yeah.
The second solution is also there's a problem because you cannot just release the data to everyone. Mm-hmm. Right?
Yeah.
Because especially of the privacy issue.
Yeah, especially if we're talking about medical models.
Right. Yeah. And so the solution that we propose is, okay, what do I do if I cannot give you the gift, or I cannot give you, the money, right?
Yeah.
How do I ensure that you're still happy,
Okay.
The solution that we propose is basically we just give you a collection of gifts so that you can pick it, right? So what I can do is that I can find something in between, right? I can say, okay, maybe instead of giving you a single one, I can send you a collection of gifts.
Okay.
And then I can ask you, okay, which one you like. So that's kind of the analogy that we are doing. Like, so we're saying that instead of just deploying a single model, right, we start off by learning a collection of model, right?
Okay.
And then deploy this collection of model, and then at test time, the user can pick which one is the best model for them.
Okay.
So that's the idea basically of our poster.
Okay. It sounds specific, but I think our listeners can understand. I mean, at least those who have not already left for birthday cake. After listening to you, Okay. Very, very interesting. Is there anything else you'd like to tell us about this event, this international conference on machine learning? Have you enjoyed it so far? Did you meet interesting people, new collaborations?
Yes, that's the ultimate goal. I think to talk to people, not only people I already know, but also to make new friends, new colleagues, new collection, or start a new collaboration. And of course, visiting the booth, getting free T-shirt, that's something I haven't actually accomplished yet. So I need to get some. Because every time I visit the conference, I go back with a new T-shirt every time.
Do you have an extensive T-shirt collection?
Yeah, I have an extensive collection of T-shirts.
Nice. But in the past, have there been any collaborations that you actually found at conferences? Is it like a really important part of your research?
I think it's really important part of research in general that people. And sometimes we start off by reading a paper of some people, and then we find interesting, and then we meet the author of the paper at the conference, and then we start talking, and then that's initiate the new collaboration.
Yeah, sounds really interesting. And I think actually Vienna is a great city to do quite that, because it's just lovely, sun is shining.
Yeah, it's very lovely weather. Right?
And I don't really want to keep you any longer. I've already stolen your coffee break. So please go back to poster sessions, to talks, enjoy the big research topics that are being discussed here. And I fingers crossed for some new collaborations, and of course for free T-shirts. Thank you very much, Krikamol.
Yeah, thanks for having me.
Sure. See you later. Bye.
See you. Bye-bye.